So welcome back. Today we are going to talk a little bit about density and pressure. The density, rho, of an object is its mass per unit volume. The SI unit for density is kilograms per meter cubed. Density is also sometimes given by grams per centimeter cubed. To convert between the two, simply multiply your grams per centimeter cubed by 1,000 and you'll have kilograms per meter cubed. So water at 4 degrees centigrade has a density of 1 gram per centimeter cubed, or 1,000 kilograms per meter cubed. The specific gravity of any substance is the ratio of that substance density to that of water. Pressure is defined as the force per unit area. Pressure is just a scalar, it's not a vector. The units of pressure in SI system are pascals, with a pascal being a force over an area, 1 Newton divided by meter squared. So at a given depth in a fluid, the pressure is going to be the same in every direction. If it were not, the fluid would flow in the direction that it's not equal to until it was equal. If a fluid is sitting at rest, then there's not going to be any pressure that is parallel to a side. If there was, then, like in this case, the fluid would flow up the bottle until there was no longer any force. The final situation here, a pressure at a depth h below a surface is due to the weight of the liquid above it. We can calculate that pressure, which is force over area, force of what? The force of the volume of this column here, which is mass times gravity. Now that mass can be put in terms of density and volume. That volume, of course, is just area times height. I can cancel out this area. I'm left with pressure equaling to the density times gravity times height. Now this relationship is valid for any liquid whose density does not change with depth, or in particular the depth that is h. So for the first problem, what is the mass of a solid iron wrecking ball of radius 18 centimeters? So we can solve this using our density equation and a table of known values. Iron is a pretty common thing, so the density is probably well known. So I get the volume first by using the radius that I'm given. We've got 4/3 pi r cubed. Plug in some numbers and I get 0.024 meters cubed. Now combining what I got from a density table, a 7,800 kilograms per cubic meter, times the volume of the iron that I just got, I'm going to get a wrecking ball that's equal to 190 kilograms. Another problem. So we have the surface of the water in a storage tank, 30 meters above a water faucet in a kitchen. Calculate the difference in water pressure between the faucet and the surface of the water in the tank. So this is just a density and pressure problem. We're going to have a change in pressure equal to the density times gravity times the change in height. All we really need to know is the density of water and gravity, and we can go to town. So the density of water being 1,000 kilograms per meter cubed, gravity being 9.8. Plug in the numbers, and that's it. So this is actually a bit of an unfair problem, as usually in the industry, when we're talking about faucet pressure, we'll talk about the pressure head, which in this case is just 30 meters pressure head. But yeah, this is an example, and now you know how to do pressure problems. So go do it. Thank you for watching. Please remember to check As You Learn for the remainder of your assignment.